Alright, so we're given a problem here and told that there's a mechanic and they're recording miles driven and gallons used for the school bus. So you have this table here and you want to realize what are my variables here for this? Well, they kind of give it away, right? You've got gallons that are being used for each school bus, but the other variable aside from gallons really is miles driven. The connection between how much gas you have and how far you can go. That's what we're looking at here. You can see it here in the table. The bus numbers are different, right? 1, 2, 3, 4, 5, 6, 7, and 8. But what's happening here? Well, the gas used, right, is 5 gallons, and we get 80 miles. So if you want to think of a rate, how many miles per gallon is usually a rate that we look at, right, for each of these. So just to think about the data we're given, you would define miles per gallon, you would do miles divided for each gallon. So for a little table here for bus number 1, what's our MPG? Well, it's 80 divided by 5, and that's what? Well, 5 times 12 is 60, so 5 times 16 is 80. So it's 16 miles per gallon for bus number 1. So we can make a little table here and set this up. I'm going to drag this heading over here, right? So this is miles per gallon, and here this is the bus number. So we can get a sense of how the different buses compare to each other. For bus number 2, we have 100 divided by 8, right? And what's that? Well, 8 times 12 is 96 with the remainder of 4, so it's 12, right, and a half, 12.5. For bus 3, we have 180 divided by 12, right? And what's that? Well, 12 times 10 is 120, and there's 60 left over, so it's 12 times 10 plus 12 times 5, right? Because 12 times 5 is 60. So that's 15 miles per gallon. Bus 4, we have 15 gallons and 225 miles. So 225 divided by 15, that's just 15. And keep going. 280 divided by 18. Less friendly, but we can still do it. Think about the fact that 18 times 10, right, it's down here, 18 times 10 equals 180. If we double that, we get 360. That's too large, right? So it's not 18 times 20. What's 18 times 5? Well, that's just 5 times 10 is 50, plus 40 is 90, and we're almost there. That's 180, and 90 is 270. So that means 18 times 15 gets us 270. So what does this mean? Where are we going with this? Well, bus number 5 is 15 with a remainder of 10, but 10/18. If we reduce that, right, we get 5/9. 5/9 is 0.5 repeating, so we have that. Bus number 6, 290 divided by 20, and this is actually not so bad if you think about it, because 20 times 5 is 100, right? So 20 times 10 is 200. We need to get up to 290, right? How many times is 20 going to 290? So that's 20 times 15, or another 5 20s is 300. But we need 290. So 15 would be too large. So 14 times 20, without calculating, you can think in terms of subtraction now. That's 1 less 20. That's 280, right? 20 times 15 is 15 20s. Now we have 14 20s. Now so far we have 14 gallons, right? Because 20 times 14 is 280, with the remainder of 10, or 10 out of 20, which is 1/2, so 14.5. Bus number 7, we have 320 divided by 22. Okay, well, 22 times 10 is 220. 220. There's a remainder of 100 to get to 320, and I know 22 times, well, 4 is pretty close. That gives me 88. All right, so what do I do now? Well, I have 22 times 10, 22 times 4. It goes into it 14 times with a remainder of 12 over 22. What is that? Well, divide both in half, we get 6/11. So it's 14 and 6/11. And last bus. Okay, finally an easy division problem. So 25 into 375. Think of quarters into dollars, right? There are 4 quarters per dollar. With $4, that would be 16 quarters, but this is 1 quarter less, that's 15 quarters. Why did I do all that? Well, even before I read the questions for myself, I want to kind of get a sense of how these different buses are operating, which one's the most efficient, which one's the least efficient, because really the two main variables are miles and gallons, right? That's the relationship between. But there is a third variable in a sense where we're looking at different buses. So we're trying to put all that together, and you can just identify here, excuse me, that it seems to me that bus 1 is the most efficient because it has the most miles per gallon. And on the other side of the spectrum, we have bus number 2, which is the least efficient, right? Because it has the least miles per gallon, so it really uses a lot of gas. Okay, so let's talk about the question now, and if I haven't lost you yet, my rambling. Write a linear equation that models the relationship between miles driven, D, and gallons of gas used, G. So there are different ways to be precise now about the answer to this question, because we are not looking specifically at just one of the buses. We're looking at all of them. Each bus would be a little bit simpler, right? We know the rates here, so I could say any equation for the first one, for example. My distance equals 16 miles per gallon, so 16 times the gallons I have equals the distance I go. In the second one, it's 12.5 times gallons equals distance. In the third one, it's 15 times the gallons equals the distance, and so forth. But altogether, what do? Well, one approach is to average them, because we're modeling with the mathematics. And here, if we add these up, and it took me 3 times to add this up, I'm not very good at entering data into a calculator, plus 15, add them all up. So for an average, we get them all in there, plus 14.5, plus 14.54 repeating. That's the 6/11ths plus 15. Okay, you have this number. You want to find the average. Divide by the 8 buses, right? Divide by 8. And notice we get this number. Now this could be your rate, 14.7626 repeating. So you have a choice to make. You're going to use this number, 14.7626 repeating. Double check that's our number. Or do you round up to 15? Well, I feel like in this case 15 is a good enough approximation, but maybe not. Maybe if you're running the bus company, you want to round down a little bit to 14.7, right? Because if you round up, that assumes that your buses get a little bit better gas mileage than 14.7. And if you did that, maybe you would lose money because you thought you would get more miles per gallon than you did. So maybe the safer bet is 14.7. Maybe you want to be as precise as possible and use this number here. Whatever the reason, you want to choose a number that's the closest average to all of them. I'm going to choose the most precise number because why not, right? We have that value. So 14.7626 repeating times our gallons, that's our average gallon efficiency, equals our distance for our bus company. And there's our formula. So now we want to predict, right, the number of miles such a bus could travel on 10 gallons of gas. Well, plug it in, right? We have 14, I'll put it on here now. So you have 14.7626 repeating times gallons equals distance. So we have 14.7626 repeating times 10 gallons. How far will we go? Well, multiplying by 10 is easy. We just move our decimal once to the right. We can go 147.626 repeating, right? And that is our distance right there. Okay, got that. Now we want to do something a little different. We want to use your equation to predict the number of gallons of gas required to travel 250 miles. So we have our equation, 14.7626 repeating. Now we want to find the gallons if given the distance, 250. And the gallons will just equal 250 divided by 14.7626 repeating. It's just an inverse relation, right? If we had something times G equals 250, then 250 divided by the number gives you G. It's a basic fact family kind of principle, right? 3 times 5 equals 15, for example. Well, then 15 divided by 3 equals 5, right? Basic inverse operation. So here we do the division. And our division, I'm going to use a calculator for help here. 250 divided by 14.7626 repeating. Right, and then now 16.93, that would be what? Well, that would be the gallons we need to use. So G is equal to 16.93, right? 4 about. That's how many gallons we need to go that distance. So now we've got that. Now the last thing is D. What values of M and B? What do these represent in our equation? Well, M is your slope, so that's your rate. And B essentially is how far you would go on 0 gallons of gas. It's your y-intercept, which would be 0 here, right? Your bus is not going to go if you have no gas. If G is 0, imagine, I'll show you the equation. Imagine that, oops, scroll down a little bit. I'm going out of room, right over here. D equals mg plus b. Well, we write distance equals, again, 14 as our slope, 0.7626 repeating, times gallons, right? That equals our distance. But really, it's plus b, or plus 0. And the idea is that if you have 0 gallons, well, right up here, if g equals 0, what would happen? Well, 0 times anything is 0, and your distance would be 0. So there's that common connection you often see in linear equations here as well. Thanks.